As I mentioned online, we are hitting the home stretch. This will be the last assignment guided practice that we will do together. For the remainder of the semester after this week, you will be working on writing your own program, a program of your choosing, and I'll talk a little bit more about that at the end of the video. So for now, we are going to cover recursion. And what recursion is simply a function that calls itself. So you might think, well, if a function calls itself, wouldn't you get kind of stuck in an infinite loop? Well, what you do in your recursive function is you give it a base case that will allow for the cycle to resolve, so to speak, and then other cases will then have a recursive call breaking down the problem just a little bit more until it gets finally down to the base case. So make sure you've read the chapter 14 PowerPoint notes and the chapter 14 out of the Savage text so you can be familiar with this concept of recursion. So I'm going to create a brand new project here, and this one is coming from the end of chapter 14. It should be number 1 in the old text, and I believe it's in the first 5 in the new text. The problem asks to write a recursive function definition for a function that has one parameter n of type int that returns the nth Fibonacci number. And then they describe the Fibonacci number sequence in chapter 3 if you look at project 10 in chapter 3. But basically what the Fibonacci sequence is you start with 1 and as the zeroth element, and then 1 is the first element as well, and then to get every other additional element you add the previous 2. So 1 and 1 is 2, and then 2 and 1 is 3, 3 and 2 is 5, 5 and 3 is 8. So 1, 1, 2, 3, 5, 8, and then 5 and 8 is 13. So that's the Fibonacci number sequence. We're going to write a program that solves that using recursion. We're actually going to do this with iteration as well. So what we're going to do is compare the two. So I'm going to call this project Fibonacci recursion versus iteration. And create a folder for it. Fibonacci recursion versus iteration. And that's what I'm going to say here in the description. Come on. And today's date. I'll say this program compares recursive versus iterative algorithms which compute the nth element of the Fibonacci sequence. Okay. I'm going to have this be a menu-driven program. So I'm going to start with a couple of variables here. The user's choice, and I'll have it be a string. And then I'll also receive the element that the user would like to see. I'm going to call it int nth. Starting the menu, I'm going to have it do while. title this Fibonacci. Actually, yeah. Okay, I'll say calculate nth element using recursion is going to be the first menu option. Actually, if you don't put a semicolon at the end, then you can wrap. Okay, and then my other option, calculate nth element using iteration. And then I'll also have exit. And I'll prompt the user, enter their choice. And I'm just going to use a regular cin statement to grab that string. And then for my menu decision structure here, I'm just going to use an if, else if. So if string choice is equal to the string 1, remember that we're reading it in as a string. If you wanted to make it an int, you could make it an int and read it in as an int. Okay, so string choice is 1, do something, else if string choice is 2, do something else. And then this while loop, this do while loop, it's going to continue while string choice is not equal to 3. So if they type 3, then that will break the loop and end the program. Okay. So after I get their choice, I also want to know what nth element they want. Now, could I ask them that within each function? Yes, but when we write the Fibonacci function with recursion, the function is going to call itself, so we don't want it to keep prompting the user over and over again. So I'm going to do all that stuff right here. So I'm going to ask the user, what nth element would you like to find? Have them type that in as well. Oh, and also the recursive function is going to need to receive and pass to itself a value. So we're going to just read that in right here. What nth element would you like to find? Read in nth. Okay, and then for choice 1, I'll say this needs to be a cout statement. And then I'll display what nth is here. And then element is and I'm going to call this function Fibonacci with recursion, passing to it that nth element. Okay, and same thing here, only a different function, Fibonacci with iteration. Okay, so these two functions, of course, I haven't written yet, and I'm trying to call them before they're defined or declared, so I'm just going to declare them first up here at the top. Okay, so I'll have both of them I'm going to have return an int. They're returning the nth element. So first one, int Fibonacci with recursion, it receives an int that we'll call nth, and that description there, I'll say this recursive function returns the nth element in the Fibonacci number sequence. And then the other function, same thing, only it's iterative. So I'll take this, and if you're not, or if you haven't heard the word iteration before, it's what we mean by that is loops. So this can be solved using a loop, right? Obviously, and that's probably the first thing that popped in your mind when I told you what the number sequence was, or if you knew it beforehand. It's just taking the previous two, adding them together to get the next. So you could create a loop that does that. The advantage of recursion over iteration, and you will see in your textbook it will say just about any program, or I think it says every program that, or every function that can be written with a recursion can also be written with iteration. And that may be true, but the ease of writing a function with recursion is what its appeal, or what the appeal of a recursive function is. They're easier to write. They're a lot simpler to think. The logic is a lot simpler. So anyway, we're going to compare these two, and you'll get the idea here. There's some times in programming where recursion, is just absolutely the easiest way to do something. Some navigating through a file structure, for example. File folders have subfolders, so you could have a recursive folder that, or function that, looks through every subfolder, and then that function could call itself to look through the other subfolders. Okay, so let's go ahead and write this Fibonacci with recursion. Okay, so what you should have read in the text and maybe seen in the PowerPoint, with recursive functions you have a base case, and this is the case where the iteration, or the recursion stops. And in my case here, or in our case with the Fibonacci sequence, if they choose any number, or once n is less than or equal to 2, then we just want to return nth. Okay. Otherwise, what we're going to do, remember we said that the Fibonacci sequence is just the previous two added together. So I'm going to call Fibonacci with recursion and then do nth minus 1, and that's what I'm passing to it. And then add to that Fibonacci with recursion, passing to it nth minus 2. Okay, so to get any nth element, you just add the previous two. So those will call those and subtract 1 from those, and as they come through, they'll keep calling one another, and you'll get this expansion, this exponential expansion kind of going on here, or a binary tree maybe. You think about it that way. The first call is the top node, and then it calls two functions. So these functions will just keep calling functions below them until one of them calls a number that's less than or equal to 2. Once it does, it returns that number. So that's it for Fibonacci with recursion. I want to test that one out. I'm going to comment out this line here where we call the iteration, just so we can test this function. But see how simple that recursive function is? Well, how do I find the previous, or any element? Add the previous two. So this thing will recursively work until it gets down to 2 and 1 where the sequence starts. So I'm going to run this. Oh, I forgot the data type up there, nth. Okay. And we can only use number 1 right now. So choice 1, what nth element would you like to find? Let's start with one we know. 0 is 1, the first element is also 1, second element is 2, third element is 3, the fourth element should be 5. Okay, that worked. Let's try the fifth element, not the movie but the number in the sequence. 8, that's correct. Let's try the sixth element. Choose choice 1 first, sixth element. Sixth element is 13. Okay, so we got a working recursive function that finds any element in the Fibonacci sequence. Very simple to write. Okay. Now let's take a look at the iterative case. And you'll see with this one it's a lot more complicated. The code is going to be a lot more complicated. Int Fibonacci with iteration, passing to it int nth. Okay. So with this one, if we start with 1 and 1, then we add those two together and keep recursively going. We're going to have to start with an integer that we keep track of the growing value, or the total. I'm going to call it nth value. Start it at 0. And then I'm going to call nth minus 2. I'm going to set it equal to 1 to begin with. And then int nth minus 1, set it equal to 1 to begin with. Okay. Now, same with the iterative function. If someone tries to find the 0 or first or second element in this function, or in the sequence, we don't really need any recursion. So I'm going to do if nth is greater than or less than 2, I'm sorry. If nth is less than 2, then we just return 1. That's the answer. Otherwise, we go on to do the iteration. Which will be a for loop. Starting, and instead of, I'm going to use I, just so I don't get nth and n confused. So I'm going to go int I equal to 0. That's my iterator. I less than or equal to the nth element, I plus plus. Okay. So then the nth value is going to be equal to nth minus 2. Oops, sorry. Plus nth minus 1. Then, before the loop goes back, we need to bump every element down. So now nth minus 2 is going to be equal to what nth minus 1 was. And then nth minus 1 is going to be that previous value, or the value that we just found, as it loops back. And then once that's all done, then we can finally return nth value. And that this is definitely not trivial. It took a good probably 15 or 20 minutes for me to hash through that and figure out how I was going to do it, because you have to start with 1 and 1. So then if you add those two together, that'll give you the second element. So for example, if the user passes 2, oh, I'm sorry, yeah, I am wrong. This shouldn't start at 0. This should actually start at 2 if we're going to do it this way. So if 2's passed in, then this thing will only iterate one time. So if it'll continue as long as I is less than or equal to 2. So it'll iterate once, and 1 and 1 will be 2. And it will bump all of those down, but then the loop will break out of it after its first time, and it will just return 2. So why don't we just try it, and I'll prove it to you. Before we do, we need to go ahead and comment this back in and run it. Okay, choice 2, let's try the iterative case. I want 3, element 3 is 3, that's correct. Let's try the iterative case again. Let's try element 4, we get 5. Let's try the iterative case again and try element 5. We get 8. Okay, so they both appear to be working the same, but as you can see, the recursive one was a lot easier to think through and program. Now here's where it gets sticky. Let me try larger numbers. Let's try the iterative case to find the 35th element. Okay, iterative case just cranks it right out. Boom, the 35th element is 1,493,000. Actually, I'm wrong. It's 14,930,352. So that the iterative case slammed it right out. But if we try the recursive case now and do 35, okay, there's just a slight pause. Now let's try the 38th case. So I'm going to do the 38th with iterative. Boom, it just calculates it, blink of an eye. If I try the recursive case now, 38th element, okay, and another noticeable pause. Let's try the 40th element. Running it with iteration, no problem. Running it with recursion, a little bit of a pause. You can see how it's getting slower and slower. So that's the drawback. And if you try something even larger, let's try 50. Long pause, and we'll see if it even finishes. Recursive functions, the problem every time a function gets called, you're adding another function to what's called the stack. And you should read through your text and familiarize yourself with what the stack is. And if you have too many function calls on the stack, there's a special area of memory that's reserved for that. If you have too many function calls, then you get what's known as Stack Overflow. Many of you may be familiar with that website. That's a very useful tool for programmers, one of my favorites. Stack Overflow means, they get their name, they take their name from this idea that if you have too many function calls in a row without any of them getting resolved, functions calling other functions, it actually gave us a negative number there. So you can see memory was completely taken up, and our int, I guess that's outside the range of our int perhaps. But at any rate, when of course, then I want to do it with iteration, then no problem. Again, that's not the correct answer because our integer doesn't support. You could go double and maybe get into that range, but or long. But anyhow, recursion, it's a great tool. You need to know that it's an option. You should have it in your toolbox so that you can use it when it's easy and when it is the easiest way. Sometimes it's going to save hours of programming. As long as this thing doesn't expand to larger and larger, larger and larger numbers, it wouldn't work. So it depends on what it's being used for. Now, that's recursion, and that's our final topic in C++. We've covered a lot. Appreciate all of your hard work. As always, make sure you get your assignments done and get them turned in. I will receive your assignments, still receiving any of the old ones for points. And then next week we'll start on our personal projects. So I already have the programming project button available for you on Blackboard. It's at the bottom here. If you click on it, you'll see actually two items, survey. And this survey, all I want you to do is tell me what program you're wanting to write. I say, what program would you like to write for your personal project, game or app? Describe. This is worth 5 points, just filling out this survey. I want you to do this week and just get started thinking about what project you want to write. And I encourage you to go ahead and start this week. Not due until the end of the semester, but the more time you give yourself, the better your program will be. So I have a grading rubric here, some ideas, and then this is where you'll submit it. Let's take a look at the grading rubric first. Okay, so this thing's worth 50 points. Runtime is 20. So I'm going to try to make your program crash. If it doesn't crash, then good, you've handled all of your issues. Or not just crashing, if it doesn't do what it's supposed to do. That's also an error, runtime error. Formatting, I'll take a look at your code and see how easy or how clean it is, how easy it is to follow. If it were to be a project that, let's say, some other, or me as another programmer would come in and need to make changes to it, how easy would that be for me to read? Your logic, how efficient was your logic, if you could clean it up, in other words, if your program could run effectively, more effectively or efficiently with some slight logical rearrangements, then I might count a few points off. And then effectiveness and design. This is going to be the user interface. If you're going to write this in console, like all of our programs this semester, then how clean and neat does it look? I will post a video next week of some examples from the past semesters. You can see what students put together. And so some of them did quite a bit with console, changing colors and all that. Those of you who would like to try to use forms, you're more than welcome to. There's some there's some GUI options out there, but not required. I'm just looking here to see is the program easy to use and does it look clean. Okay, the other items here under materials, ideas. So just a few ideas here. A card game is a good idea. Here I said accept war. That's actually I stole this from my C# class. If you want to do the game of war, you can. Since we didn't do it, we did that together in my C# class. Those of you who haven't taken C# yet, you definitely can do that with me next spring probably. And anyway, just a couple ideas here. Some regular tic-tac-toe, I guess that's the one we should say we didn't do. You can't do because we already did tic-tac-toe. 3D tic-tac-toe would be an awesome option if you've ever played 3D tic-tac-toe, where you have the boards are 4x4 and there's 3 different levels. Sudoku, 9 Men's Morris is a game I'm into quite a lot now. Some of you may have come across that, maybe in Assassin's Creed video game. Anyway, these are just some options for you. Pick an idea and then fill out this survey and let me know what you plan on doing this week. So happy programming. Know yourself.